Today we're going to introduce logarithmic functions. Today we're going to practice transforming log functions into exponential. Once we transform them, then we're going to practice solving. So again, today what we're going to use is my trick using the acronym BAY. So first I'm going to start off by showing you the parts of the exponential equation. So if I gave you this equation, 2 to the third power equals 8, everybody should recognize that the 2 is the base and the 3 is the exponent and the 8 is the answer to my problem. Everybody good so far? So this is where I'm going to get the letters for the word BAY. I'm going to use the B from the base, I'm going to use the E from exponent, and I'm going to use the A for answer. So what I'm going to do is when I want to transform an exponential function into a log equation, I'm going to write the word log, and then I'm going to spell out the word BAY. So I'm going to take each one of the numbers and I'm going to put it in here. And then I'll put the E over here. So to transform 2 to the third power equals 8, I'm going to write log. I'm going to put the 2 here. Then I'm going to put the answer. And then I'm going to put equals the exponent. So you're going to spell out BAY. The base of the log is always the same number as the base of the exponent. So go to the next slide. So the definition of log here, this little subscript here, A, is called the base of the log. The A in the exponential equation is also the base of the exponent. So the bases are always going to be the same. The graph of a logarithmic function is going to sort of look like a reflection of the exponential function. So when we go to graph our logarithmic functions, we can turn them into exponential and do a table of values. Now we're not going to graph the logarithmic functions until Monday. So today we're only going to practice switching from a log to an exponential. Okay, so let's try that. Everybody good so far? So let me just clarify here. So your exponent or exponential equation is going to look like this, and your log is going to spell out BAY. So let's go ahead and practice this. So you may have other techniques that you use to transform, but I don't care how you do it. If you use my acronym, that's fine. But just be able to go from a log equation to exponential or exponential to log. So today we're going to go from log to exponential. So let's try this. So what I like to do when I'm first practicing this to get the hang of it, I'm going to put the letters next to the numbers. So the 2 is the base, the answer is here, and exponent. I'm writing the word BAY here. To turn it into exponential, we're going to write the base, the exponent, and then write our answer. Once we transform from log to exponential, the equation you're writing needs to make sense. If 2 to the third power did not equal 8, then you've done something wrong. Pretty good so far? All right, let's try the next one. Again, it helps me to write B, A, E, and now I'm going to switch it. So the base is 1/2, the exponent is -4, and my answer is 16. And again, when you have a fraction raised to a negative exponent, think reciprocal. So really what this is doing is flipping it, making it positive, and then it does become 16. So if this equation does not make sense, you've put it in the wrong order. All right, everybody, the next one. BAE. Again, 10 to the 5th power, and the answer is 100,000. Next one, BAE, 3 to the negative 4th power, and it's 1 over 81. Again, remember negative exponent turns it into a fraction. Next one, BAE, 5 to the 1st power, and it equals 5. Number 6, BAE, 3 over 4, or 3/4, raised to the 0 power. What's anything to the 0 power? 1. And it makes sense. So the whole reason behind this is these are inverse operations. So sometimes if you're given a problem and it's in logarithmic form and they ask you to find the value of x and you can't do it, you don't have a calculator, then switch it to exponential form, and then sometimes you can do it. Now there's other times where it has to be done with a calculator. Now when we take this quiz, it'll probably be all things that you can do mentally, like the examples that we can do today, or we'll do the change of base. So just like tomorrow's quiz. So let's go ahead, and now we're gonna switch it first from log form to exponential, and then we're gonna be finding and solving for a variable. The variable may be the exponent, or the variable may be the base. So here's my first example, and it's asking me to solve for x. Now, when I look at this, I'm like, I can't do this without a calculator. So I am going to convert it to exponential form, and then I can solve it. So again, I'm going to put in my BAE, x to the 3rd power equals 8 over 27. Now, once we turn it into exponential form, now we're back to 4/2. And this is what you're taking a quiz on tomorrow. So remember to find a base when it's raised to a power. I'm going to cube root both sides. So the cube root, and this gives me x equals 2/3. So now once we switch it to exponential form, all of the examples I'm doing today could be potential quiz questions tomorrow. Again, in log form, I can't solve it. However, if I change it to exponential form, I can solve it. So BAE, 4 to the 5 over 2 power equals x. So for here, all I'm doing is simplifying 4 to the 5/2 power. Again, remember the denominator is the root, the 5 or the numerator is the exponent. So the square root of 4 raised to the 5th power. Now, if you were to get this question tomorrow, just this part, not necessarily a log, you would do the square root of 2, and you know it's plus minus, and then you raise that to the 5th power. And you would get plus and minus 32. What we're going to learn with this log section is we cannot find the log of a negative number. So when we're asked to solve something like this and it's a log equation, we're going to throw out the negative number. So what I needed to do here, instead of doing plus minus 2, I'm just going to keep the positive 2, and then the answer is only 32 for the log. When you hit the log button on your calculator, if you were to touch the button that says log and then put in a negative number on your display, it's going to display the word error. You haven't entered it wrong, you just can't take the log of a negative number. Whenever the variable is right here, this number cannot be negative. It has to be positive. So when the variable's there, if you were to square root something or fourth root, do not use the negative of that answer. Let's try the next one. Again, I'm going to put it into exponential form. 49 to the x power equals the cube root of 7. This could be a potential quiz question. What base do I want to make both sides?
7.
Good. 49 is 7 to what power? Good. Drop the x. What about the cube root of 7? 7 to what power for this one? Nice. Now that I've changed them to the same bases, get rid of the 7s and work with what remains. 2x equals 1/3. I'm going to divide both sides by 2. 1/3 divided by 2 is like multiplied by the reciprocal. So my answer here is 1/6. Now, before we go on, keep in mind, I know we haven't practiced this on our calculator, but we will. The log button on your calculator is always solving problems in a base 10. So this little number that's right here is the base of the log. So whenever you touch the button on your calculator that says log, it's always calculating a base 10. So if I were to touch the log button and then put 10, it would give me my answer for base 10. Now, if the problem has something like log of base 4 of 10, then we have to change the base. The newer calculators actually will do it for you. Some of the older calculators won't do it. The way that you can get to this is you're going to touch the button that says math, and then you're going to scroll down until you see the word log base. You'll hit that option, and then it should open up the cursor, and it would let you put in a little 4 there. However, the older calculators, you're going to have to do it by hand. And I'm going to teach you the change of base formula next week. Now, for those of you who have the newer calculators, you still need to pay attention to the change of base formula, because in the past, it's appeared on standardized tests, whether it's the AP test for calculus, an SAT. So be able to describe what the formula is in case you get this on a standardized test later. And I'm going to do a whole day of change of base next week. So for now, we're not doing any of the calculations with our calculator, but we'll work more with our calculators next week. So here again, I know I already talked about this on the previous example, but I'm going to show you why we can never take the log of a negative number. So if I were to give you this problem, log base 4, and then have negative 3 equals x, if I add in my bay, and I turn it into exponential, 4 raised to the x power equals negative 3. I'm going to show you if I put in a positive number, a negative number, and 0 to show you that no matter what I try to put in for x, I'm never going to get a number that's going to equal negative 3. So if this occurs and you see the word log, and then you see a negative 3 or a negative number here, you're going to tell me it's impossible or you can't do it. Because watch what happens when I plug in a 1 for the exponent. I get positive 4. If I plug in 0 for the exponent, I get 1. If I plug in a negative number, it doesn't make the number negative, it makes it a fraction. So when I plug in negative numbers, I get fractions and it gets smaller. If I plug in positive numbers, the bigger the positive number, the bigger the answer gets. So I will never get a negative number out of a log. So just remember, when you do this on your calculator, it's going to say error, and don't think you've done something wrong. Just remember, it's impossible to take the log of a negative number. So let's continue practicing solving for the next one. Now, in order for my Bay trick to work, whenever I have something like this where it's x equals, I'm going to move the x equals to the other side so I can spell out my acronym Bay. So 3 is the base, x is the exponent, and 1 over 81. So this is the example where you said, could it equal a negative number? Yes, it could, because in order to get a fraction, my exponent here has to be negative. Yes?
Can you just put this into the calculator?
Okay, but you're going to get the quiz without the calculator.
Mm-hmm.
Yes.
But, like, on like the test.
Be a quiz question tomorrow. I'm going to do change of base. I'm going to make the 81 3 to the negative 4. And now that the bases are the same, get rid of them, and x equals negative 4. Now, again, some of these are easy. You can look at them and you can figure out what that exponent is. Yes?
Will we get like fraction and exponents?
Yes. There was one at the bottom. Okay, here's this one. Again, I can move it around the back so I can spell out Bay, B-A-E. So 6 to what power gives me 1 over 216. So again, this could be your quiz question tomorrow. I'm going to make the 1 over 216 have the same base as the left side. So I'm going to make it 6 to the negative 3. Get rid of the bases, and x equals negative 3. As soon as you see a fraction, you should be thinking negative exponent. The next example, let's try the next one. Oh, I got to go back. There's more than one way to do this. Next week, we're going to be learning properties for the logs. So here, there's actually a property called the power property. And what this power property for logs says is if you have a log and you're taking the log of a number that's got an exponent, you can take that exponent, put it around the front, and then it's being multiplied. So if you wanted to do this on your calculator, you could find the log of base 100 of 10 and multiply it by 8. This is what the power property does. You're gonna be asked to simplify logs. However, since we haven't learned the power property yet, I'm gonna still use my Bay trick. So I'm gonna go ahead and move this to the other side. So now I have 8 log 100, 10 equals x. Now, when I use my Bay trick, this has to be just log. Now, notice the 8 and that log are being multiplied, so I'm going to move it to the other side by dividing. So now I have log 110 equals x over 8. Now I can spell Bay, B-A-E. So 100 to the x over 8 power equals 10. I now need to change the base. What are the bases going to be?
9.
Good. 100 becomes 10 to what power? Good. And then put the x over 8. I'm going to put a 1 on that 10. Get rid of the 10s. So 2 times x over 8 becomes 2/8 x equals 1, or 1/4 x. And to solve for x, I'll multiply by the reciprocal. And x equals 4. All right. So what kind of equation is this? This is an exponential equation. Notice the 12 is the base. So this right now is in exponential form. So if I wanted to convert it back to log, let me go ahead and move this over here. This is my base. This is my exponent. This is my answer. So if I want to put it in log form, log 12 equals log 12 of 5. So now to solve this, as long as I keep things balanced, I could cancel the log 12 on both sides, and I'm left with x equals 5. Now, one of the things we're going to learn next week is whenever the base of the exponent is the same number as the base that's in your log, this is going to cancel. And we had an x in front, so then another way to solve this is just x equals 5. So whenever the base of the exponent is the same as the base of the log, they're going to cancel each other out. Let me show you another example of it. So let's say it's x equals 5 log base 5, 7. So whenever the base of this exponent is the same as the base of the log, cancels, and I'm left with x equals 7. Yes? No. Next week. Try the next one. Again, notice the base of the exponent is the same as the base of the log. It cancels. X equals 11. Number 9. Back to my bay. X to the negative 2 power equals 1 over 16. You might get a question like this tomorrow, what I've written in red. When you're looking for the base, I'm going to go ahead and make the exponent positive and now solve this as a proportion. I'm going to multiply diagonally. X squared equals 16. I square root both sides. Now tomorrow, you would tell me plus and minus 4. But because this is a log, I'm going to throw away the negative. But tomorrow, you would tell me both.
How can you throw away the negative? Oh, that's right, you can get.
We don't want to do a negative log. 2 more examples. Going to do base, answer, exponent. 2 to the negative 1 power equals x. And all I need to do is simplify what 2 to the negative 1 power is, and that's 1/2. Last example. Again, to do the Bay trick, let me move the x equals over here. BAE. 5 to the x power equals the 4th root of 25. I need to make them both have the same base. So I could change this first to 25 to the 1/4. And then now I can make 25 5 squared. This potentially at this point could be a question on the quiz tomorrow. Get rid of the bases. And x equals 2 times 1/4 or 1/2. Yes. Well, when you did this, log 10 of 100. So the square root of 25 is like the 100, or the 4th root of 25. Does that make sense?
So 100 just, okay.
Yep. Okay, so homework for this is due on Monday. Tonight's homework is to study for the quiz. Okay, so tonight, all you're doing is studying. This assignment is due on Monday. And that is your introduction to logs.